Okay, good morning one and all. This is Premchand, IIT Chemistry faculty. Welcome to the St. Joseph family. Today we are going to do the experiment, the creation of fake blood. So for that, the chemicals which are required, one is potassium thiocyanate, another one is ferric chloride, and the next one is sodium fluoride. It acts as a dissociation agent which will split the potassium cyanate into cyanide. That will result in the disappearing of the blood. So now we are going to start the experiment. Again, get back. This is Premchand, IIT Chemistry faculty. As I said earlier, we are going to do the practical explanation of the fake blood. The chemicals which we require is potassium thiocyanate, ferric chloride, and to make the solution disappear, sodium fluoride, acting as a dissociation agent. Already explained. So now we are going to add the chemicals into this 100 ml conical flask. Make sure that you have idea that this is a 100 ml conical flask already filled with the distilled water. So now we are going to add a potassium thiocyanate, and we have to maintain one more most important thing, maintaining individual spatulas for each and every chemical, because when we combine chemicals with the same spatula again and again, there may be a chance for a new reaction to occur. To eliminate that and to overcome that, we have to use each and every chemical one separate spatula. Now see this, I am taking potassium thiocyanate into a conical flask containing 50 ml distilled water. So after that, we have to keep the spatula down. This is the rule that everyone has to follow. After completion of adding this potassium thiocyanate into a conical flask, we have to keep it aside. And next, again ferric chloride solution. Sorry, this is a powder. We have to take this one also, again with another spatula. See. Again, we have to take with the spatula. We have to add into another conical flask with a capacity of 50 ml water. Again downwards. We have to close this. After closing the cap and everything, we have to keep this ferric chloride also aside. After, we have to take sodium fluoride into another beaker. This is also one spatula enough, but we have to make sure that we are not touching this directly. We have to use gloves. That is very, very important. After adding sodium fluoride also, we have to keep it aside. Now on continuous stirring, the salt will dissolve in the distilled water completely. So this is how. Now the salt is disappeared. That is potassium thiocyanate. It is ferric chloride. Now we are going to mix this solution also completely. On continuous stirring, the solution will dissolve. And now this sodium fluoride. See this. Disappeared completely. After disappearing, now the reaction takes place between potassium ferric chloride, potassium thiocyanate. See what happens. This is a 100 ml conical flask, an empty conical flask. Into that I am going to add a 50 ml potassium thiocyanate and a 50 ml ferric chloride solution. See what happens. This is the reaction. Potassium thiocyanate, which when reacted with the ferric chloride, produces a solution which is completely similar like blood. That's why we used to call this as fake blood. Hence, the demonstration of the reaction between ferric chloride and potassium thiocyanate has been completed. But now, is it possible to make the solution transparent like how we are having before adding all this? Yes, possible. For that, the solution is too heavy in this conical flask. We'll take into another one. This is already prepared sodium fluoride solution. So when we add this sodium fluoride solution to the solution which is combined with the potassium thiocyanate and ferric chloride, is it going to disappear? Isn't it? We'll see. Demonstration complete. This is not magic. This is what the chemistry, and I'm not a magician. As an IIT chemistry faculty, I feel very grateful to have such an opportunity by the management to explain all the practicals at the very beginning level for you 7th class. Felt very, very happy. Thank you all. Okay, sir.
Good morning to everyone. This is A. Kaushal Kumar from class 8 present before you to do the experiment so-called flake bin. And these are my companions.
My name is Sheikh Asid. I am from 7th IIT2.
My name is Jashwant. I am from 7th IIT2.
Now we are going to do the experiment. Now this is potassium thiocyanate and this is ferric chloride and it is sodium fluoride. Now we are going to make the experiment so-called flake blood. Now we are going to take a spatula. For each we have to take different spatula as they may react and form a new solution. So first we are going to take potassium thiocyanate. Now we're gonna take one scoop. Actually, it is filled already with distilled water. Now potassium thiocyanate is dissolved in it. We have to keep the spatula aside. Now in another beaker, this distilled water, we're gonna add ferric chloride anhydrous. So, what is the meaning of anhydrous? Anhydrous means it consists of no water molecules. Now, we are going to add it. As we can see, these are very highly reactive, so we need to wear some protocols like mask, gloves and hair wraps. Now we can see the color. So we are going to keep the spatula aside and we are going to fold it again. As you can see, these gloves protect me from the ferric chloride anhydrous that is very reactant to our skin. Now, in another distilled water beaker, we are adding sodium nitrate. Now we're gonna add a spatula of sodium fluoride in distilled water beaker. Now, when we mix this potassium thiocyanate and ferric chloride anhydrous, we are gonna get the fake blood. Let's mix it in another beaker. Now we got the fake blood. As you can see, it is similar to the blood of a color. Now I'm gonna ask my companion, can we make this color to return to its normal state?
No.
Yes, we can. When we pour this solution into the solution of sodium fluoride, now we can see that it's returned to its original state.
Wow, what a magic.
It's not magic, it's basic chemistry. Now we can see that the fake blood is disintegrated into other substance. Now we can see that this is red color flake blood, but now just white color liquid. So I thank the management and chemistry faculty, Mr. Premchand sir, for giving me this wonderful opportunity to do this so-called experiment called fake blood. Thank you.
Good morning to one and all. This is Tarunika from 7th standard IIT1.
This is Said Shabana from 7th IT2.
This is T. Divya from 7th IIT1.
This is potassium thiocyanate. This is ferric chloride. This is sodium fluoride. Now let's start the experiment. Take a conical flask which already contains distilled water. Now let's add the potassium thiocyanate. With spatula. Now stir it well until it dissolves. Now take another conical flask which already contain distilled water. Now take ferric chloride and which is in anhydrous state. Now take spatula and add it. Now take sodium fluoride to another conical flask which contained distilled water in it. With the help of spatula. Now stir it well. Now let's the magic starts. Now take potassium thiocyanate and ferric chloride to 1 beaker. This is called flake bread, which looks like real bread. Take sodium fluoride to make the solution transparent. Now add flake bread to the sodium fluoride. See this magic, it turns transparent. This is called dissociation agent. Thank you for giving me this wonderful opportunity from the management and our grateful faculty, Premchand sir.
Good morning everyone. This is K. Anvita from 7th class, present here to show how fake blood is formed. First,
I'm Ishwari Lasasri from 7th IT1.
I'm Sheikh Amina from 7th IT1.
I am Indishita from 7th IT1.
At first, I'm gonna mix potassium thiocyanate. I'm going to add potassium thiocyanate into this beaker. Now we are going to stir it. And the atomic mass of potassium thiocyanate is 97.18. And the formula of it is KSCN. Now I am going to add ferric chloride. Now, the formula of ferric chloride is FeCl3 and the molecular weight of it is 162.21. Now I am going to add sodium fluoride. To form fake blood, now we are gonna mix this potassium thiocyanate with ferric chloride. Yes, this is what we call as fake blood. This is so amazing, right?
Yes,
Do you believe that if it will disappear by adding sodium fluorine?
No.
Yes, I'll show you. Now I'm adding sodium fluoride to this. See, the color has disappeared. Now by adding sodium fluoride, the color of the fake blood will be disappeared. Thank you. Thank you for giving me this opportunity.
This is Premchand, IIT Chemistry faculty from St. Joseph. Today we are here to discuss the artificial snow by using the chemical called sodium polyacrylate with the formula C3H3NaO2. This is being a super absorbent. It has wide variety of applications, like as we see the pampers, the so-called diapers used for the children. It is having this sodium polyacrylate chemical to absorb the more amount of water. Right now, is it going to absorb? That we'll see. With a spatula, we have to take some amount of sodium polyacrylate into a 100 ml beaker containing distilled water. So now see, will it act as super absorbent? We'll come to know now. After adding whatever the chemical it is, we have to keep the spatula downwards. Remember that. So now, you see we added sodium polyacrylate to the water. You can notice clearly the crystals are converting and making this liquid water into a solid substance. And this is what after a while we call the so-called artificial snow. Am I clear? See this, completed. There is no water in this. How fast is it, the reaction? Yeah, this is no water. No water. This is what the wonder, that is the chemistry. And at last, want to tell you one thing, want to do wonders, come let's be the Joseph in you too. Okay, thank you. Now we are going to see the reaction between a metal called sodium with a Latin name natrium, because of that either that symbol is Na, which is in first group with atomic number 11. Sodium is a second most highly reactive metal in the periodic table after potassium. Now sodium is highly reactive with water, and that's the reason we have sodium in paraffin wax. After removing the paraffin wax, we have to cut the sodium. This is sodium metal. Okay, see this, that shining appearance, that is called as luster. All the metals possess luster. The shining appearance, by time you notice clearly, this is disappearing. That disappearing is due to the reaction of oxygen with the sodium. That reaction is called as oxidation. What we call? Oxidation. So now sodium metal is oxidized. This oxidation metal formula is Na2O. Am I clear? Now this oxidized sodium metal formula is Na2O. Now the Na2O, when we add it to the water with the formula, what is the water formula? So when we add Na2O to the water, what happens? The solution is so what is the color of the flame when sodium metal is reacting with water? Golden yellow. Okay, see this. This is sodium metal piece. This is water. Second most highly reactive metal in the periodic table. Now see this. We'll have some golden yellow flame. Due to the paraffin wax, we are not getting the flame exactly, but we'll get now. That is the flame color, golden yellow. I'll show you one more. See, that is the golden yellow flame. Now, so the solution is completely basic. This is a red litmus paper turned into blue. What is the nature of the solution now? Basic. Hence proved all the metal oxides are basic in nature. Am I clear? Okay. Thank you. Thank you all. Your support and the management support and the encouragement by you and by your parents and students like you will make the teachers to learn something more and to explain something more that is not possible at this level. I'm very, very thankful to all of you for your support and for your hard work. Once again, thank you all. Signing off. Bye.